If you have a minor arc, it measures less than 180 degrees, okay? Which is less than half of a circle. Half of a circle is 180. You skateboarders know that, right? And a whole circle is 360. And you name it with 2 letters. So a minor arc in this picture would be arc BC. You go from B to C, you don't stop, you go the closest distance. Technically, I could go around the bottom of the circle to get from B to C, but when there's only 2 letters, you go the shortest distance. Do you understand that? So if I want to talk about a major arc, and I made the wrong turn, I have a friend that's late for everything because she gets lost and goes the long way every time. Every time. So let's say I want to do a major arc. It measures greater than 180. And you need 3 letters to name it. And that forces you to go the long way. If you look at arc BDC, does everybody see how you're going to get there? You go from B through D and go to C. So that would be a major arc. You need 3 letters to show which way you're going. If you have a 180 degree arc in a circle or 2, it doesn't really matter which way you go. And you've seen that on Waze and Google Maps or whatever. It says, here are your 2 routes, and they both take the same amount of time. You pick which one you want to go on, okay? So then it's just like the scenery or, the roads you like. So if I want to find the measurement of arc BC, which would be the little guy at the top, and I know the measurement of this angle here, BAC, so if measurement of angle BAC equals 89 degrees, what is the measurement of arc BC? Does anybody know? If angle BAC is a central angle, that means it comes out, it's in the center of the circle, it's a central angle, the measurement of the arc that it hangs on to is the same measurement in degrees, okay? We're going to talk about arc length in a minute, but in degrees it's the same. So if I have a circle and I can measure it in degrees, I'm going to draw like 3 different circles here. 1, 1, and 1. What is the measurement of degrees of all of those 3 circles? 360. It doesn't matter what. It doesn't matter what size it is. Any circle measures 360 degrees around, okay? But if I were to buy rope and create these circles on the floor, do they each take the same amount of rope? No. And that's where arc length comes into play, okay? So arc length comes into play when you're trying to figure out how much rope you need to go around the circle. So let's talk about that. What is it called when we measure the outside of a circle?
Perimeter.
Yes, the perimeter of a circle is the circumference. And we talked about that last week, right?
Yeah.
And we talked about circumference is equal to diameter times pi, or 2 times radius times pi. Either one are the formulas for circumference, all right? So if I have an angle here that is, let's say, 30 degrees, and I want to know how much rope I need, or how long is the crust of pizza, because that looks like a pizza to me, right? How long is that piece right there, the length of the arc? I know that that length of the arc is a portion of the whole circumference, correct?
No.
What fraction of the whole circumference would it be?
30.
So if I have 30 degrees over 360, that is the portion of the circle. And it's not 30% of the circle. That was an SAT question I was doing with an SAT student yesterday, and they got it wrong because they put the 30 in as the answer, but it was different degrees, okay? So what is 30 over 360? That should be 1/12 of the circle. Okay? And you can reduce it or let the calculator do all the heavy lifting. Now, I want to know, let's put in a radius now. Now we're going to talk how much rope I need when I go to Home Depot. Let's say the radius is 5, right? What is the circumference of the whole circle?
10 pi.
10 pi, perfect. Diameter times pi, Yagunka pi, right? So if I take, if the circumference of the whole circle is 10 pi, and I just want 1/12 of that, what do I do?
Divide by 12.
Yep, multiply 10 by 1/12, and you get 5/6 pi. And for the length, you can type in the pi button, because you want a number. You want to know how much rope to buy. If I were to walk into Home Depot and I say I need 5/6 pi length of rope, they're going to say, right? So somebody multiply 5/6 by pi. Use the pi button, not 3. So it would be 2.62. And I need that in feet or meters or whatever it is that I'm measuring my circle in. Okay? I can find out how much rope I need. It's very easy to find out how much rope I need in this room to go around the classroom because there's straight lines. When you've got curvy lines, it's a little harder to tell what you need. So you've got to use pi to figure that out. Okay. The radius is 6. If I know the radius, do I know the diameter?
Yes.
What do I do?
Multiply by 2.
Multiply it by 2. If you answer, don't answer the next question. What is the circumference? Somebody else. Yes?
12
12 what?
pi.
12 pi. What is the measurement in degrees of arc AB? Dylan?
120.
120 degrees. Little bubble. Somebody else. What's the measurement of X?
150.
And how did you get that?
120 plus 90 degrees minus 360 minus the sum of those two.
Yes. All of these central angles, this guy plus this guy plus this guy, are all of the central angles add up to 360. So just like in a triangle, we subtract everything from 180. Now we're dealing with 360. All right? So it would be 360 minus 120 minus 90 will give you the X guy, which is 150. Okay? And what is the length of arc BC? What are you going to do to find the length of BC? What angle, what central angle creates BC? How much is that angle that creates?
950.
Huh?
150.
No, BC.
Oh, BC 90.
90. So it's going to be 90 over 360, which is actually 1/4 of the circle, times 12 pi, which would be 3 pi. And you put the pi in the calculator, so it's going to be 9 point something.
9.424.
Agreed.
Okay?